Hello everyone, I am Sal from Thara. I'll be explaining you a presentation about understanding self-organizing map, which is also called as SOM. So, in this video, we will learn about what is an actual self-organizing map, how it works, flows, and its advantages, disadvantages, and some takeaways. So, let's start with the video. So, first of all, what is actually a self-organizing map? A self-organizing map or SOM is a type of unsupervised learning. It helps us to take complex and high-dimensional data and represent it on a 2D or 3D map. So, it performs mainly three main tasks. First of all, first task is unsupervised learning. In unsupervised learning, meaning it it has no predefined labels needed. And second one is dimensionality reduction, which means it converts large multi-feature data into smaller or more understandable form. And the third is reserva- uh, preservation of topology. So, in this, the preservation of topology means the data points which are same or which are close together, which comes close together. Let us now learn about the learning process. There are four stages in the learning process. First is the initialization stage. At the start, all the neurons give random all the neurons given a random weight values and a grid of neurons is created. In the competition phase, for every new input, all neurons compete to find which one is most similar to the input. The neuron that is closest to the input is the best matching unit or the BMU. And in the corporation stage, after the BMU is chosen, its neighboring neuron is also get activated based on something which we call is as neighborhood function. And the fourth stage is adaptation. Finally, when the BMU and its neighboring neurons update their weight move closer to the input pattern. And after that, let us see now how self-organizing map actually create clusters. Each time an input is given to the neurons compete to each time an input is given, the neurons compete to become the BMU. The winning neuron and its neighboring then update their weights to resemble that input. Over the time, simpler inputs keep activating the same nearby neuron, forming the clusters of the same data on a map. So, best matching unit. There are three main concepts in the clustering mechanism. The best matching unit, the neuron whose weights are almost similar, neuron whose weights are most similar to the input. Second one is neighborhood function. It controls nearby neurons also learn. The learning rate. It decides how the weight should adjust after each iterations. After that, let us see about the real world application. The real world application of self-organizing map is the customer segmentation in marketing. Let us see we have data of customers such as their age, spending amount, shopping frequency and location. Some process is done in this data and maps it into 2D grid. The grid visually separates the customer into different segmentations like premium customers, regular customers, or budget customers. This will this is very helpful for the business because it reveals hidden relationships in the customer behavior that normal clustering methods might get missed. It allows marketing team to target the right group more, customer group more effectively. After that, let us see the advantages and disadvantages of self-organizing map. It can discover patterns, meaning similar data points stay together. It preserves topology, meaning similar data points stay together. It provides initiative 2D visualization for high-dimensional data. It also affects for dimensionality reduction, helping large data sets. And when we talk about the limitations of it, that training training it on a computational way is very expensive for very large data set. It requires very careful parameters tuning like adjusting learning rate and neighborhood size. The result can depend on the grid topology chosen. For extremely high dimensional data, interpretation becomes very difficult. After that, let us dive and let us see that why self-organizing map matters in soft computing. Because it helps to get the bridge the gap between the raw data and human understanding. It empowers engineers and researchers to visualize complex information by reducing thousands of data dimensions into 2D map. Automatically discover hidden patterns and clusters without predefined labels. Make faster and smarter decisions based on relationship seen in the self-organizing map. Thank you for watching this video and have a great day.